Hello everyone, welcome to my Monday, October 5th video. Today is actually National Do Something Nice Day and National Get Funky Day. Cool, I like those two. It was really good, so I put both up there. But I hope you guys had a good weekend and a good start to your week. So today we're going to be talking about atomic models, okay? About the history of an atom, and we've been talking about elements for a little while, so what we're going to do is we're going to analyze what they actually look like. So I'm going to run through a few slides, and then I'll have an activity for you guys to do at the end. All right, so first, there's this genius called Democritus. You might have heard of him before, but Democritus, he's from 400 BC, 4th century BC, so he's very old. But he's the first guy to come up with the term of an atom, and that the universe was made of these atoms. Okay? And then about 200 years ago, which is a long gap between these two guys, we met, I think his name's Henry Dalton, and he still felt the atom was the smallest unit. And those atoms can combine to make compounds. So as you can see down here, if you have one oxygen and two hydrogen molecules, you create H2O, in other words, water. Now, this will help you with the worksheet, all right? This will help you with the worksheet, all right? So the protons have a positive charge, and they have a mass of 1 AMU, atomic mass. Now, the AMU is, I think, 1 times 10 to the negative 16th grams. Very, very, very small, all right? Very small. Now, electrons have a negative charge, and they barely weigh anything, all right? Like, they are not considered when trying to figure out the mass of an atom. And then the neutrons are neutral, and they weigh the same as a proton. Exactly the same, not quite, but very similar. All right, so this is kind of what an atom looks like, where you have a nucleus. The nucleus is where the protons and neutrons are, okay? It's positively charged because all you have is positive protons and neutrons. All right, very small, very dense. But then on the outside, you have what's called the electron cloud, and that's where the electrons are. All right, and electrons are negative, so that's where all the negative sits. Okay. Now, this guy created, how did the nucleus get discovered? Now, this guy called Ernest Rutherford, what he did was he shot a laser at a gold foil. And what he saw was that some particles shot to the side. Some shot to the other side. Some shot right back. And some went straight through. And he's like, what? Why is this happening? And he determined that there's a dense nucleus in the middle of the gold foil that is making the laser bounce different directions. Okay. And then along came Bohr, and now we have Bohr's model, and this is what we're going to be using today. We're going to be using this two-dimensional Bohr's model where the protons and neutrons are in the nucleus and the electrons are in the electron cloud. Now, what I want you to see here is there are 2 electrons in this first circle. Okay, that is because there are only 2 elements in the first period on the periodic table. There's only hydrogen and helium. So that is why there's one. The first circle only has 2 electrons. Now the second circle can actually go up to the golden number. All right, the golden number is 8. So you'll have 8 valence electrons in the second circle. And in the third, you will have 8 valence electrons. That's the golden number. Fourth, 8 valence electrons. Fifth, 8 valence electrons, etc. Okay, so that's kind of what the Bohr's model looks like. And eventually, probably in the next chapter, we'll get to 3D models. All right, this is what the atom looks like. It's actually like a sphere, like a cloud, and you can create different orbitals. Okay. Hopefully that made sense. Okay, of what you see, what it looks like. So that's what an atom looks like. All right, a little background of what each element might look like. Now, what I want you guys to do is I go to the classwork tab, complete the atom, ATOM, the PhET assignment, okay? You will answer the questions, okay? Answer the challenge questions as well. And then after doing the challenge questions, what I want you guys to do, you do not have to do the games, all right? I leave 4 blanks for the games. You do not have to, unless you want to. It's good practice. It's a little fun. It's a little cheesy, but it's a little fun. But try out that assignment, all right? And let me know how you do. There is one thing I actually do want to discuss real quick, and it's what the nuclear equation, I guess, looks like. All right, I'm going to write it down on this piece of paper. Okay. Now, what you have, when you get to question number 7, when you get to question number 7, what does nuclear notation look like? When you have that, what it looks like is, I'm going to write it out and then show you. Okay, so you have 3 things. You got mass on top, mass number. You got the amount of protons on the bottom, and then you have the element symbol. All right, so for example, if I have 4,2 helium, well, helium is number 2 on the periodic table. That's why I have 2 protons. All right, if I have 2 protons, how many neutrons do I have? Well, to solve for neutrons, you have to subtract those 2 numbers. All right, so 4 minus 2, I have 2 neutrons. And then from this, we cannot determine how many electrons we have. However, if there is a charge or minus, you might be able to. But this is what you will write. This is an example. All right, I think in the problem you will be doing fluorine. All right, so try solving those. If you guys have any questions, please let me know. A lot of you guys are doing awesome. We're at interim, so about halfway through. But if not, have a great day. Keep up the good work, and we'll see you tomorrow.